All right, page 290 in your textbooks, and we've been talking about three words that all start with M: mean, median, and mode, and we need to know the difference. When we hear the word mean, class, we need to think one word. Average. When we hear median, we need to think one word. Middle. When we hear mode, we need to think two words. Most often. Good. Now, in order to tell what the middle number is, you have to do what with the data set first? Joel?
Salt, pepper.
Well, that's how we arrive at the median, but before we can even do that, we gotta... You're close. Rank the data. Yeah, put them in order numerically. It helps if you rank for finding the mode as well, because it helps you to see the most often numbers together, but you must rank data in order to find the median. And number 18, Francesca fishes at the local reservoir. Best place to fish, stocked ponds. Anyway, the following are the known, especially around feeding time. When they're like, okay, we're going to turn on the feeder, that's when you want to go fishing. I will admit, I feel like a little bit of a cheat, but that's how I caught my biggest ever catfish. It was about this big. The head was about that large. It was a massive catfish. But I cheated. I did it when the feeder had gone off, and all the catfish were coming to the dock to feed. And so I had my bait ready, and I saw this massive swirl off to one side of the dock. So I cast, and it was perfect cast. It dropped right in the center of the swirl. Bam! The fish hit. I fought it for about, 5-10 minutes. Finally got it landed, and that thing was enormous. It was fantastic. Have never caught one that big since, and that was like 15 years ago. So it's been a long time ago, but there's my fishing story. I cheated. All right. I also caught, in my lifetime, I've only ever caught one bass. I caught a lot of catfish, only one bass, and it was an accident. I was fishing, and my line got caught on something, and so I was tugging on it, trying to get it loose, doing all the stuff you do to try to get the line loose. And it finally came loose, and it shot over my head and landed on the back end of the dock. Fortunately, there was nobody back there. So now I got to go back there and get the line loose, and it was stuck on something. And when I got it loose, there was a 13-inch bass on the other end. It was totally an accident, but I caught something. So there's my one bass. So yeah, success as a fisherman, minimal. Francesca, on the other hand, probably a better fisherwoman than I. And she has caught 2 fish, 0 fish, that's more like me most of the time. 4 fish, 10 fish, 10 fish, that's awesome. 3 fish, 6 fish, and 1 fish. First thing we need to do, class, put all those numbers in order. Or in other words, rank them. 0 is sad. 1, 2, 3, 4. 4 is pretty solid. 6 is really strong. 10 is a really good day. And the first number I would find is not the mean, because that requires work, and I'm lazy. So the first number I'm going to find is actually the mode, because that requires no work. And what is the mode, class? No mode. Nothing repeats itself. Then I'll find the median, and that requires only a moderate amount of salt and pepper work. And once we salt and pepper, we find her median catch is 3. And then we actually have to do the math, because I come back to the mean, and I'm like, okay, I got to add them together. Well, I know 4 and 6 makes 10, right? And there's another 10, so I'm up to 20. And there's 6 more, so that's 26. Now, what do I divide by? 7. Even though there were no fish, this was still a time she went out fishing. So the total number of values is 7. And 7 doesn't go evenly, but 7 goes in how many times? 3 with how many left over?
5.
And I would just leave it as a fraction unless it tells you to write it as a decimal. 3 5/7, because that's a really annoying decimal. It doesn't ever end. It repeats 6 digits at a time. That's really obnoxious. How many have this mean, median, and mode for Francesca's fishing excursions? All right, there we go. Questions on number 18. Yes, sir.
What if we, is it okay, are we doing it in, putting the remainder in the fraction or in the decimal?
Well, I just said that if you were listening, class, and I said if, when in doubt, unless it tells you to, leave it as a fraction, because that's easier. We're lazy. We don't want to make it a decimal unless we absolutely have to. Let's take a look at number 19. Yes, ma'am. For a quick question first.
So, I think I'm doing it wrong because I got like the 5, but then I added like another decimal.
So yeah, so you got 3.714285 repeating if you did it as a decimal. I don't want to get that as a decimal. Now, it's not wrong either, right? If you said approximately 3.7 fish, like I'm not going to call that necessarily wrong if you've done the work correctly, but 3 5/7, I didn't even have to do that much work, right? So, yeah, be lazy. Fraction. Unless it tells you decimal, fraction's easier. Good question. Number 19. English class, Mrs. Starr gave homework assignments with the following number of problems. 15, 18, 12, 20, 9, 10, 14, and 16. Well, just reading it, class, what's the mode?
No more.
No mode. Again, there's no mode there. Median. We're going to have to put them in order, right? So I should have written down 9, 10, 12, 14, 15, 16, 18, 20. Make sure, hold on, there's 1, 2, 3, 6, 8. 8, okay, good. And so we salt and pepper a few off the ends, and we have 2 middle values. And class, what do we do to find the median when there's 2 middle values? Add and divide by 2. Add and cut it in half. So if we, or, like literally, what's exactly halfway between 14 and 15, class? 14 and a half, right? So, I mean, 29 divided by 2 is 14 and a half. Or if you just want to bypass that and say, no, it's going to be smack dab between 14 and 15, it's going to be 14 and a half. We could do that as well. And then for the mean, got to add them all up. Let's see here. I'm going to say 10 and 20, class, makes how much? 30. And 14 and 16 makes how much? 30. And 12 and 18 makes how much? 30. The only numbers I used are 15 and 9. That's not quite as easy to do in our head. What is that? 24. So if I add it that way, I end up with how much? 114. Now you don't have to add in that way, pairing them up, but hey, if I can see numbers that end in zeros by pairing them up, like I know a 2 and an 8 is going to end in a 0. I know a 4 and a 6 is going to end in a 0. Obviously 20. So anyway, just a little shortcut strategy tip for adding. How many total data values we said? 8. So we'll divide by 8. 8 goes into 11. 1's with 3 left. 8 goes into 34. 4 with how many left? 2 left. Now I'm not going to leave it as 14 and 2 8s. Let's reduce that and say 14 and 1/4. Again, if you had 14.25, that's not wrong. And there we go. Any outliers in the data set? No. So the mean is a good estimator of the middle, though notice the median and mean are very close anyway. Coming over here, any outliers in this data set? 10. The 10 is, I mean, considering these are all within a gap of 1, 1, 1, 1, 2, a gap of 4 is certainly the biggest gap. It's not that much bigger. I could make the case for 10 being an outlier. I mean, it's the only time she ever hit double digits. So, I mean, one might argue it's an outlier. I do think here the median is probably a better estimator of normal, but again, if it's an outlier, it's a weak outlier. Questions on 1819. Questions on mean, median mode. We get pretty comfortable with this. No issues with mean, median mode. Good. Let's take a look at number 21. And they give us a little dot plot here of how many cups of coffee people order at the coffee shop. And the mode is how many cups of coffee per customer. What happens most often? Luciana?
2.
I got a stack taller than the 2.
5.
The 5, yeah. So most people coming in will order 5 cups of coffee, at least more often than any other one individual number. That doesn't necessarily mean 5 is normal. Do we see an outlier, class?
No.
There is a break from the rest of the data. It's not a strong outlier, but the 7's kind of off there all by its lonesome. I mean, you could argue 7's a little bit of an outlier. Number 22, dog walking company. How many miles each dog walked per week? And what's the mode of number 22, Kirsten? There really is no mode. I mean, 2 and 3 both slightly rose above the rest, but it was so slight. I just say no mode. There is no normal for how many miles a dog walks. Now, I will say most of the dogs were under 5 miles, right, each week. So maybe we say under 5 is normal. Questions on the 21-22, reading a dot plot. All right, look across the page now. Let's take a look at some questions you had to answer. And we talked a little bit about this yesterday at the end of the hour. We're going to talk more about it today, but some terminology here says, which type of probability is based on what is observed, Griffin?
Experimental.
Experimental probability. We actually have data on what type of pitches a particular pitcher throws. And we know that 62% of the time he throws a fastball. We know that with 2 strikes, 38% of the time he throws a curveball, whatever, right? We have observed data, so we can say, okay, there's this probability that this will take place. That's experimental probability. What type of probability is based on just what is expected? Bryson? Number 2, pay attention, boy.
Yeah.
Help him, Jalen. Theoretical probability. So we say that, for instance, a Corvette comes in 6 different colors. So the odds of somebody picking a red Corvette is 1 to 6. Well, I mean, that's theoretically the case. Realistically, I mean, who wouldn't want a red Corvette? You know, so anyway, like the new Corvette. Anyway, but theoretical probability just says, look, assuming it's all even odds, right? Assuming that, you know, you're blindfolded and you don't really get a choice. You just walk up, touch the Corvette, you know, the first Corvette you touch. Well, okay, then if there's 6 Corvettes sitting in front of you, you got a 1 in 6 chance of picking a particular color. But if you have no blindfold, you get to pick which of these colors you want. Well, there are certain colors that are more popular than others. That would be experimental. Theoretical is kind of the blind test, so to speak. Number 3, we talked about this earlier. What type of table shows the number of times an event occurs? For redemption, Bryson. Frequency table. We talked about this way back when we first started talking about statistics. Talked about a frequency table. However, which type of table shows the probability of an event occurring based on past history? And what would that be, Corey? Oh, we should have looked it up then. Don't be lazy. Ben, what you got?
Probability.
No, not a probability table. It's kind of another name for probability.
Hypothetical.
No, you didn't look this up either. Come on now. Bryson?
Oh, relative frequency table.
Relative frequency table. Write that answer in if we missed it. Relative frequency table shows probability of something occurring. So remember yesterday at the end of the hour we said 10% of you would want Snickers, 70% of you would want Skittles, and 20% of you would want Whoppers. Well, that's relative frequency table. But when we just listed 7 of you wanted Skittles, and 1 of you wanted Snickers, and 2 of you wanted Whoppers, that's frequency table. How frequently did this happen? Okay, now let's make it probability. That's relative frequency, relative to the total number. Look at number 5. They give us a relative frequency table. And at a particular sports event, 33.3% of the people who ordered a beverage. 16.7% of orders were for pretzels. 8.3% were for popcorn. 41.7% were for hot dogs. Do you notice how it's giving us probabilities? That's a relative frequency table. Okay? So what they asked about in number 4, that's what we're seeing here in number 5. Number 5, what is the probability of a fan buying a popcorn or a pretzel? Wait a second. Probability or, class, what do you suppose we should do here? Add. So we look at popcorn, we look at pretzel, we add them together, and what do we get for number 5? Back to Corey.
1 to 4.
A 1 to 4 probability, I would just leave it as 25%. That'd be easier. 25%. If they've given it to us percent, I don't want to make percents, but they've already given us percents. Number 6. You didn't do this one, but let's do it now real quick. What's the probability of a fan buying a beverage or a hot dog? What's the probability of a fan buying a beverage or a hot dog? Joel?
75%.
75%. Good. Questions on those? I meant to assign number 6, realized I failed to do so. Make that edit for next year. They get number 6 also. How many did number 6 anyway, just because it was right there? Yeah, it was logical to do. I just, for whatever reason, did not assign it. So next year's class, 1 through 6. All right. They won't get out of it. All right, let's drop down to the bottom of the page. Number 8. I want you to read through that problem, find the mean median mode. Do number 8 at the bottom of page 291. Zoo animals, or people visiting zoos. Yeah, number of visits from zoo people. Pencil down when you've got it. In fact, if you would stand next to your desk once you've got all 3 answers for number 8. The mean, the median, and the mode. Bryson, Luciana, Jalen, Griffin. Lots of people finishing up here. All right, have a seat. Michael, you get first crack at this. Michael, let's start with the easiest one, and that is the mode. What is the mode?
No mode.
No mode. There's a couple threes, there's a couple fours. Really no one number that rises above the rest. Then we go to the next easiest number, which is the median. What was the median number of visits?
2 1/2.
Oh, all right, we go to Elaine. I assume you had no mode.
Yes.
All right, what was your median?
3 1/2.
Should have been 3.5. Careful, should have had a 3 and a 4 as the two middle values. And so that would have given you 3.5. So then we come last of all, Elaine, to the mean, where we had to add them all and divide. What did you get for your mean?
4 3/10.
4 3/10, or if you went 4.3, that would be correct. Anyone else get them all correct, just not quite as fast as Elaine. All right, any questions on number 8? Nice catch. All right, Flame, right at your face. All right, down to number 9. Do number 9. How heavy are various packages sent out from this shipping company throughout the morning? Mean, median, mode. That was close. I think she was up a hair ahead of you. I saw her out of the corner of my eye just before I heard your crash. And then Luciana third. A little bit bigger numbers this time. That was really close. Jalen, a hair ahead of Joel? Okay. All right, have a seat. Well, let's take a look at these answers. First of all, Elaine, the mode for number 9.
16.
16. Barely, but a mode. Then the median, Elaine.
15 1/2.
15.5 ounces. And then just under 1 pound. And then for number 9, the mean.
15 3/8.
That is correct, 15 3/8. Did you also get them, Michael? Yeah, just a hair slower, if even a hair. See, we'll give you a different flavor this time. All right, then look at number, short toss. Look at number 10. We got a survey of asking students, hey, outside of school, just for your own pleasure, how many books do you read, or did you read last year? What's the mode? Pretty obviously, class. 5. And again, a graph just really helps. A dot plot just really helps to visually see things. So, helpful way to see that data. Look over at page 288 now. Flip back a page to page 288, and let's go through a couple of these relative frequency tables. Go and read right above number 1. Read that little blurb next to the chart, if you would, Joel.
The recent
Census.
asked the question, how many children are in your household? The chart on the right shows the probability for each category?
All right, so we see the little relative frequency table there. And number one, what's the probability of a household having only one child in it, Joel?
32.1.
32.1% of households that answered the census had just a single child in there. How about number two, what's the probability of a household having either one or two children, Michael?
78.3.
78.3%, very good. We just add the 1 and 2 together. For number 3, what's the probability of a household having 2 or fewer children? What do we have to do this time, Ben?
46.2% plus 10.2 and 32.1%.
Good, we're going to have to add together the 0 kids, the 1 kids, and the 2 kids, or what's the other way we could do it, Kirsten?
Take the answer from number 2, 78.3%, and add 10.2%.
That's true. We could just build on our answer to number 2. That wasn't what I was thinking of, but you're not wrong. There we go. Jalen, what's the other way?
You could subtract 11.5 from 100.
That's what I was thinking. Take the 100%, just take away the 3 or more kid number, and that would give it to you. Either way, what do we get for our answer for number 3? Do you got it, Ben? Okay, we've been working on it there. Corey, do you have it already? What you got?
88.5%.
Good. Again, I think the easy way there is either subtract the 3 plus from 100%, or we already got 1 and 2 for number 2. Tack the 10.2 onto that to get your 88.5%. And number 4, what's the probability of a household having 2 or more kids? The probability of a household having 2 or more kids. Bryson, what do we do?
You add the 46.2 and 11.5.
There we go. Just add the 46.2 and the 11.5 to get what? Doing it quickly there at your seat.
57.7%.
There we go. 57.7% is correct. Questions on those? Seem pretty easy to read a relative frequency table. Okay. Look across the page, page 289. Let's look at the numbers 9 through 12 and read the little blurb next to that one for us, if you would, Griffin.
For 2 weeks, a coffee shop owner recorded what food items customers ordered with their coffee. The chart on the right shows the probabilities for each category.
All right, so number 9, what's the probability a customer will order a muffin with his coffee? Well, that shouldn't be too hard to find. There, Griffin?
20.3%.
Yeah, 20.3%. What's the probability a customer will order a bagel or nothing with his coffee? Just wants coffee or maybe a bagel with it. Kirsten?
48.5%.
48.5%. We just add those numbers. What's the probability a customer will order something other than a bagel with his coffee? Now be careful here. Something other than a bagel. But will order something. So class, I'm not looking at the none here, am I? I'm looking at not the bagel and not the none, but a muffin or something in the other category. So, what's that answer for number 11, Jalen? Okay, she's finding it. Something other than a bagel.
45.4%.
You added bagel and other. We want something other than a bagel. So no bagel and not nothing either. Because if the customer orders nothing with his coffee, that's the none category. But we'll actually order something, just not a bagel to go with the coffee. Elaine?
51.6.
Right, we should add the muffin number and the other number and add those two things together. Maybe a scone or whatever people order with. I don't drink coffee, so I don't even know. But 51.6%. Question?
How do you know what coffee is? Coffee's not even on there.
Oh, okay, so in the original blurb, it said they recorded what they ordered with their coffee. So it's assumed that every customer that comes in is ordering coffee. What did they order in addition to the coffee? Does that make sense? So everybody's got the coffee, it's just what do they have with it? Muffin with the coffee, 20.3% of the time. A bagel or just the coffee. Just the coffee is the none category. Does that make sense? All right. And then number 12, what's the probability that a customer will order nothing, a bagel, or a muffin? So it's either just plain coffee, nothing to go with it, or a bagel, or a muffin. Back to Jalen for redemption?
Oh, wait, no, wait.
No, because there's that other little category floating over there. Joel?
It's not the answer, but I added all of the percents up and it equals 101%.
Ah, rounding error, huh? Yeah, Joel discovered just a little problem with these numbers. Anyone else notice it adds up to over 101%? Or 100.1%. So somewhere they have a little bit of a rounding issue with their numbers there. Good catch, Joel. What do we get though for number 12? Bryson?
68.7.
I'm one decimal off. I got 68.8% when you added the none, the bagel, the muffin all together. 68.8%. Questions on all that stuff? Seem pretty easy? Just add things together. Okay, now let's work on turning a frequency table into a relative frequency table. Look at number 13. Do you see how the first table they give you tell you how many different attractions are in the park? 4 carousels, 20 kiddie rides, 3 Ferris wheels, and then 13 That's a big park. 13 roller coasters. Okay, this is legit. All right, so how many total attractions in the park, class? 40. That's a frequency table. It lists the actual numbers of every item. Do we see that? But we want to know what's the probability that if a person picked at random one of these attractions, that would be the probability of that item. Does that make sense? Probabilities don't appear on a frequency table because they appear on a relative frequency table. So what we got to do is say if there's 4 carousels out of 40 total rides and a person picked a ride at random, what's the odds of them picking one of the carousels? Well, class, what do we got to do? Take the 4 carousels divided by the 40 total rides, right? 4 carousels that we could pick divided by the 40 total rides, right? The number of desired outcomes over the number of possible outcomes. That reduces very nicely, class, to 1/10, which we could either leave it as 1 to 10, or if we wanted to make it a decimal, which is usually the case, what would 1/10 be? 0.1, or if we made it a percent, 10%. 10% of the rides are carousels, therefore, if you picked a ride at random, just pointed to the little attraction map at something, 10% chance what you're pointing at is a carousel. Does that make sense? Let's go to the next one. Kiddie rides. How many kiddie rides, class?
20.
Out of how many total?
40.
We can reduce that easily to 1/2, which as a decimal is 0.5, or as a percent is 50%. All right, so you can either put the 1.1 or 0.5 or leave the percent, it's up to you. Ferris wheels, how many Ferris wheels we got? 3 different Ferris wheels, which again, for a single park, that's a lot of Ferris wheels. Normally you just have 1. But anyway, 3 Ferris wheels in the park out of how many total rides?
40.
Oh, what are we gonna have to do this time? We're gonna have to divide, because there isn't a reduced fraction form. This is the probability, but let's make it a decimal. At your seats, divide that out. At your seats, divide it out. And did we get the 0.075?
Well,
Okay, so the 4 goes into the 30 7 times, but notice that has to line up here, so 0.07, and then goes into 5 times, which we know, by the way, class, 3/4, right? 3/4 is 0.75. The extra 0 just pushes it back 1 spot, 0.075. So it makes sense mathematically there. As a percent, what would that be though, class?
0.75.
Good, 7.5%. We just go boink boink on that one. And then last of all, roller coasters. 13 out of 40 are roller coasters. You know what I'm not going to do? I'm not going to divide that. You know why? Because if 10% are carousels, 50% kiddie rides, 7.5% Ferris wheels, the rest of the percent has to be roller coasters, right? So we know the total has to be 100%. So just subtract. What percent do we already have right here, class?
67.5.
We already have 67.5%. Subtract that from 100%. What percent is left? Jalen's got it? 32.5%. If you wanted to go decimal, of course, that'd be 0.325. And so your numbers there should have the probabilities either as decimals or as percents. It's up to you. But your total number should either be 1 or 100%, unlike the bagel muffin coffee shop problem. that Joel pointed out to us. Questions on 13. Do we see how to make a relative frequency table? Just a lot of division. All right, number 14. Number 14. STEM fair exhibits. We got a big STEM fair. How many total projects are at this particular STEM fair, class?
120.
120. How many of them deal with chemistry of some kind?
32.
How many deal with electricity?
20.
How many deal with gravity?
18.
Possibly come with 18. Anyway, plant-based projects. 22, and then other 28. Let's do this. Let me have the girls row over here take chemistry, middle row take electricity, and this row over here, row 3, take gravity. That way we're not doing all the division because we're lazy. But chemistry girls, electricity middle row, gravity row 3. Divide it out, find the decimal value. Or you can make it a percent. Bless you. Bryce, did you already have the electricity number? What's your number for electricity?
10%.
I'm sorry?
10%.
Ooh, careful. 20 out of 120?
Oh,
Yeah, knock off the zeros, reduce to a sixth. Actually, we know what that is as a decimal. Middle row, what's 1/6 as a decimal?
0.16 repeating.
0.1666, blah, blah, blah. Okay, now boink, boink, what is that as a percent? 16.6 repeating percent. Or if you wanted to, you could maybe round it off to 17% if you felt like doing that. Or 0.17 if you wanted to round it off to just have the 2 digits. So middle row had the easy one, it looks like. Somebody over here on the third row have gravity.
15%.
Actually comes out evenly, 15%. So I guess this row also had it pretty easy. So gravity, if you write that number in, 15% or 0.15. Ladies, yours apparently was a little harder. You're all still working on chemistry. Tell you what, guys, while they're working on chemistry still, y'all take the plants. Y'all do plants real quick. You 6 work on plants. 22 plants out of 120. All right, Jalen's got it. 26.6 repeating. We'll say 0.27. All right, so far, make sure your chart is updated. 0.27 on the chemistry, 0.17 on electricity, 0.15 on gravity. Guys are working on plants, ladies work on other. Guys are working on plants, ladies work on other. Okay, what are we dividing right now, Ben? What are we dividing?
22 divided by 100.
Well, let's make it easier, right, guys? As we're doing the 22 divided by 120, like those are big numbers. I don't like big numbers. Let's take a 2 out of both numbers. Take a 2 out of the top class.
11.
11. Take a 2 out of the bottom, guys.
60.
That's going to be an easier division problem for you. So I would do it this way. I would divide not by 120, but by 60. 6 goes into 11
Oh, 1.
once. How many left over? 50. Bring down 0. How many times 6 go into 50?
9.
8. And that's 480, right? Subtract it 20. How many times does 6 go into 20? 3 times. Is that going to be enough to bump that up?
No.
So guys, let's settle on a 0.18, shall we, for the plants? 0.18 probability. And Luciana, do you have the other? 0.23 is what we'll put down for the other. And those should all add up to either exactly 1 or really close to 1. I'm looking at the numbers here. It does add up to exactly 1. Sometimes rounding makes it be just a touch off there. Questions on that? Check your numbers again. Chemistry 0.27, electricity 0.17, gravity 0.15, plants 0.18, other 0.23. So the total class has to be 1. Or if you did as percents, 100%. Questions on those? Number 15. Rick is a car salesman. Edgar is a car salesman. Rick has only been selling for a month, and look at his car sales in 1 month's time. Edgar has been selling for a full year. Look at his car sales over a full month's time. And they want us to create a relative frequency table for each guy. Relative frequency table for each guy. Let's start with Rick. On your paper. Get out a piece of paper. There's not room to do this right there in your book, so we're going to need a piece of paper. And we need a title for our chart. And what should be the title for our chart here? What do you think?
Automobile sales.
How about auto sales? Because I'm too lazy to write automobile. Auto sales. And maybe in parentheses, we should go and give credit to the guy who's responsible for the sales. Let's go ahead and make sure we mention this is for Rick, not for Edgar. All right, so maybe auto sales for Rick. All right, and the first categories should just mirror what they have. So the first category class should be cars. How many cars did he sell? Then it should be SUV, then truck, and then other, which is your minivans and your full-size vans and your crossovers, your hatchback. Anyway, well, I guess technically the crossover would be or a hatchback would be a car. And then in the very bottom class, we need to have a line that says total. What should the total be?
30.
No.
Oh,
100%.
100% or 1. So either 1 or 100%. If you're doing decimals, you'll go with 1. If you're doing percents, you'll do 100%. If you want to do the little lines to separate them, your paper already has lines, so I don't know that you necessarily need to draw these lines per se, but it wouldn't be a bad thing to either. How do we find the relative frequency of one of Rick's customers buying a car? How do I find it? What do I do, Corey? What?
8 by 30.
8 divided by 30. So all of you at your seat, or 8 divided by 30 is actually a pretty easy division. I like having a nice, easy number like 30. Divide the 8 by the 30. 3 goes into 8. 2, that's 60, right? 3 goes into 20. 6, that's 180. Oh, that's another 20. So it's just going to keep repeating the 6 over and over again. So let's round it off to 2 decimal places. 0.27 or 27%. At your seats, do the SUVs. At your seats, do the SUVs. Either 2 decimal places or a whole percent. And some of you can do this in your head. I'm seeing a number of hands already. What should it be for the SUVs here, Luciana?
12.5%.
Ooh. What are we dividing to find his SUV sales?
10 by, oh wait.
What should we divide?
30?
10 by 30, there we go. Divide the 10 by the 30, or reduce that down.
1/3.
Oh, which we know what 1/3 is as a decimal.
Like 1/3.
Oh, the pain, the pain. We can't forget these numbers, class.
0.3.
0.3 repeating, right? 1/3 is 0.3 repeating. So with 2 decimal places, Luciana,
33. 0.33.
0.33. Or if we go as a percent, just write,
33.3.
we'll just cut it off as 33%. We don't necessarily need to put the 0.3 because it doesn't bump it up. How many have the 33% or 0.33 there? All right, truck. How do we find truck sales? What do we need to divide, Ben?
6 divided by 30.
No, even the 6 divided by 30, kind of like the 10 divided by 30 reduced, we can reduce a 6 30th, can't we? Down to what?
1/5.
1/5. Oh, and we know what 1/5 is as a decimal class. 0.2. So 0.2, if we want to, just to stay uniform, maybe add a 0 there, just to keep 2 decimal places, or as a percent, class, 20%. And as a gift, do you notice this other is the exact same thing as truck? So class, we already know it's other. 20% or 0.20. Do we see how to make a relative frequency table? All right, now you do this for Edgar. You do this now for Edgar. Now Edgar's sales are tracking over a year. Okay, so we're doing Edgar for a year, but so that's why his numbers are bigger. Do the easiest numbers first. So if there's a number that looks easy, take care of that one first. coming on this? Anyone finished? All right, Michael's got. How many have at least 2 of the categories done? You found at least 2 of them. Which is the easiest one, class?
SUVs.
SUVs for sure, right? Because if you look at the 90 over 360, the zeros are able to drop off, and we can reduce this class to get
1/4.
1/4, which we already know is what decimal?
0.25.
0.25. So I know I've got a 0.25 or a 25%. By the way, you don't have to write both. I'm writing both for your benefit. You pick whichever one you like better. The next easiest one is probably,
Car.
I think the car, because at least you have a 0 that can knock off. So I would do the 13 over 36. Again, the zeros just cancel. It doesn't look like it's going to be real pretty, unfortunately, but at least I could make the number down to a 36 instead of a 360. Let's see, use 4 as an estimator. 4 would go into 13 class
3 times.
3 times. So I'm going to try a 3 first. 3 times 6, 18. 3 times 3 plus 1, 10. And when we subtract, we get 22. Bring down a 0. How many times would a 4 go into a 22? 5. Almost 6. I mean, this isn't quite a 4. I'm going to gamble and try a 6 here. 6 times 6? 6 times 3 plus 3? 21. Oh, that worked out nicely. Okay, I wasn't sure if it was going to cut it too close or not. It was pretty close. It almost didn't work. What do we get? 4. Bring down a 0. We get 1. Is that going to bump it up?
No.
So I'm going to leave this as a 0.36 or a 36%. Those who found car, how many had 36%? All right, now, mathematicians are lazy. We're always looking for shortcuts. There is a shortcut. Because how many cars did he sell, class? No, how many cars did he sell? Now, automobiles, cars. 130. How many other did he sell? What relationship exists? Joel, you just said it. It's half. So all I got to do is cut this in half to get the other, class. 0.18 or 18%. Oh, well now we've got all these percents spoken for, right? How do I find the remaining one? I don't have to do any division. I just subtract from 100%. Look for shortcuts is the point I'm making here. And how much total percent is being used right now? 36, 25, 18, that all adds up to 79%. How much percent is left then out of 100? 21%, which means apparently it's 0.21, and that adds up to 1 or adds up to 100%. So, I mean, not always are those shortcuts going to be there, but by all means, look for them every chance you get. And ask some questions now. Now that we did part A, create relative frequency tables for each salesman. Now part B, which salesman sells SUVs at a faster rate? Well, look at Rick, look at Edgar, look at their SUVs. Who's a faster seller of SUVs, class? Rick sells SUVs at a faster rate. Then it says, if Rick sells 200 vehicles, how many of these would we expect to be trucks? Well, class, how many trucks does Rick sell? What percent of his sales are trucks? 20%, right? Well, let's say he sells 200 vehicles. If 20% of those are trucks, how many trucks would we expect Rick to sell? 20% of 200. Find it quick. 40. There we go. 0.2 times 200 is 40. There we go. We're not going to take the time to do it, but let's just talk over it real quick. Number 16 on the next page. Nancy goes to the pond to observe wildlife. There's a big old list of animals she sees at the pond. Then she goes to a lake and she observes wildlife. There's a whole lot more critters at the lake. And we could make relative frequency tables. Now, I don't like those numbers because I don't want to divide by a 74. I don't want to divide by a 670. So those are a little bit obnoxious numbers, but we know how to do it. For instance, if you were able to use a calculator, do you see that this would be really simple? Right. All right, for homework this evening, page 294. Page 294. Do the homework 1 to 18. Page 294, do the homework 1 through 18. We have a test coming up on Friday. For those watching on YouTube, that's lesson 150. Test 10 coming up. In lesson 150, it'll cover chapter 7. All of chapter 7, probabilities, fundamental counting principle, relative frequency we were just working on, mean, median, mode, statistics, all that stuff coming up in chapter 7's test on Friday, lesson 150. But tonight, to help you prepare your homework, kind of reviews the whole chapter. Page 294, the homework 1 through 18. All right, once the bell rings, you are dismissed. Have a wonderful rest of your day.